Okay, so who could be watching the video today? Trenton and Region. Trenton, Region, we hope you guys are doing well. All right. Yes, exactly. Here we go. Sum and difference formulas for tan. Here's what it looks like. If you have the tangent of A plus B, that's equal to the tangent of A plus the tangent of B divided by 1 minus the tangent of A times the tangent of B. Yep. If it's plus in the setup, then it's plus on top. It's minus on bottom. If it's minus in the setup, then it's minus on top, plus on the bottom. Got it? Okay, let's put it to work. Look to the back side. We'll try one of the problems. Find the exact value. That's right on your sheet. So if you guys go to this sheet right here, I gave you the sheet, right? So this is up to you guys. This is your responsibility. You got to figure out how you're going to know to go to this guy right here. So I'm going to encourage you to make it a color that you know you're going to go to. That's going to jog your memory. No, I would color one box one color, and then another box a different color that you get used to going to. You're not going to use every box. Okay, so like this one right here, you know this one already. But I wanted to put one full sheet together that had really all the trig identities that you would ever need to know. So for this test, you're not going to use every single box probably because you know some of that by heart. All right. Like here, I've got law of sines, law of cosines. That was our last test, right? Okay, you're not going to use that right now. All right, so here we go. From here, I go to the back side. I got the tangent of 19 pi over 12. So first I'm going to convert this to degrees. And 19 pi over 12, in order to convert it to degrees, I will have times 180 over pi. The pi's cancel. So I have 19/12 of 180, which is 285 degrees. So I'm going to rewrite this as find the exact value of tangent of 285 degrees. Now, what are two angles that sum to 285? Or whose difference results in 285? Good, 240 and 245. You could also use 135 and 150. You could also use 330 minus 45. Any combination that gets you to 285, you can use. You make the choice. You have to come up with it. So if you look at your unit circle basic sheet, you know, there you've got a nice list of all those, you know, angles that we know perfect values for. And again, that's what you get to use on your test. Okay? Here we go. So I plug it into the formula. Tangent of 240 plus tangent of 45 divided by 1 minus tangent of 240 times tangent of 45. What to do, what to do, what to do. Somebody tell me, what should I do? Figure out what the tangent 240 is. What does your sheet say? Square root of 3. Minus what's tangent 45? 1 divided by 1 minus. Square Square root of 3 times 1. Square root of 3. What to do, what to do, what to do, do. Multiply not by the reciprocal, but multiply by the. Well, it's like we're in 1 plus square root of 3, which is the conjugate. Yes, very good. Why is it minus on the bottom? Oh, it should be plus on top. Yeah, duh. Yeah, who did that? Come on. All right. So we'll take square root of 3 plus 1 over 1 minus the square root of 3. We're going to multiply that by 1 plus the square root of 3 on the bottom, 1 plus the square root of 3 on top. There we have it. We multiply. The top we have to FOIL. 1 times the square root of 3 is the square root of 3. Square root of 3 times square root of 3 is 3. 1 times 1 is 1. 1 times square root of 3 is square root of 3. Divided by, what is 1 minus the square root of 3 times 1 plus the square root of 3? What happens when you multiply conjugates? The middle disappears. So I'm left with 1 times 1, which is 1, and square root of 3 times negative square root of 3 is minus 3. No. On top? Yeah, on top we can. So on top you got 3 plus 1 is 4. Plus 2 square roots of 3 over negative 2. Can I divide both those by negative 2? Yes. Negative 2 minus the square root of 3. That is the exact value, my friends. The exact value of the tangent of 19 pi over 12. Again, I'm not telling you what formula you got to use on the test. Yeah, but I'm going to be giving you, yeah, the sun's like trying to peek out. Totally. On the way to school this morning, it was there. So, super exciting. So, okay. Back to your question. She says, well, if it's tangent, we're going to know which one to use. But how do you know to use a sum and difference formula? How do you... Right, you're going to have double angle formulas. You're going to half angle formulas. You're going to have sum and difference formulas. You're going to have all sorts of formulas. So you got to know which formula to go to. Okay, we try a different one. Prove tangent of pi over 2 minus u is equal to the cotangent of u. So now we're going to prove. We're going to take the identities which we've learned, and we're going to make that. Now, this is tangent of a difference. So don't write this down. Everybody understand? Do not write this down. You might set it up as tangent of pi over 2 minus tangent of u, and, you know, start to go like that. But what's the problem? What's the tangent of pi over 2? It's undefined. So, therefore, since tangent pi over 2 is undefined, we can't use that type of formula. So we're going to rewrite it. I'm going to rewrite it like this. Yes. Tangent is rewritten as what? Sine over cosine. So I got the sine of pi over 2 minus u divided by the cosine of pi over 2 minus u. I need to show that that's equal to cotangent. So I just used a basic substitution. Last year I couldn't remember how to do the problem. It's like, why am I getting an undefined result? That's what happens when we walk in front of class without doing problems. All right. So, what to do? Come on. No. Use your sum and difference formulas for sine and cosine. I can rewrite sine of pi over 2 minus u and cosine of pi over 2 minus u by using these guys right here. How you like them apples? All right. So we've got, if we rewrite it, we get the sine of pi over 2 times the cosine of u minus the cosine of pi over 2 times the sine of u. over, does everybody know where I got that? It's a formula. That goes over cosine of pi over 2 times the cosine of u plus the sine of pi over 2 times the sine of u. That's what we learned yesterday for everybody who was at band instead of coming to math. You liar. We should see how many times we could remove him from class to see if he won't ace a test then. All right. So let's figure out some of these values. We can't figure out the u part, but what is sine of pi over 2? One. What is the cosine of pi over 2? 0, which totally wipes out the sine of u, doesn't it? All right. Cosine of pi over 2 is 0, so that's going to wipe out the cosine of u there. Sine of pi over 2 is 1. So really, would you agree that this stuff right here just goes away? And this stuff right here just goes away? And sine of pi over 2 is 1, so you're just left with cosine of u. And down here, sine of pi over 2 turns to 1, so you're just left with sine of u. So you have cosine over sine, which is cotangent of u q e t. Yeah, what's up? No, you gotta explode it. Come on, come on. Right. Mallory, I'm trying to be a cool teacher. Is that a cool thing to do? No, we're not. Okay. Does everybody know how to use a tangent sum and difference formula? That was a piece of cake, right? Upside down. So, could you prove an identity? You have an example to follow right here. So, oh, all right, good for you. Sums of sines and cosines. This one's going to take a little while. So, if you look at your sheet, this is what we're going to be writing down. So if you don't want to write the whole thing down, then just tell yourself to look at your sheet. But I'm going to write down this piece right here. Okay, sums of sines and cosines. Okay, that's what we're going to do. So here I go. Given A sine of x plus B sine of x, well, B cosine of x, is equal to K sine of x plus phi. Well, like in Greek, how you have the theta? Like theta is for th. So phi is for ph. So like if you want to say I love, that, like, Philadelphia, city of brotherly love, so phileo. I love. Whatever. So yeah, so that's Greek. So if you were to spell it in English, you would spell like, so. Whoop. Yeah. So you can see Philadelphia. This is the love part. This is the brotherly. So. Oh, okay. Tara's name, we'll spell that, and then we'll go into our lesson. So it's tera. So this is a rho symbol, so that's your R sound in Greek. So this is tau, alpha, rho, alpha. I'll show you. I'll show you something really cool with the alpha sign later. Okay, so given a sine of x, b cosine of x equals k sine of x plus phi, k is equal to the square root of a squared plus b squared. That's easy. Sure. Yep. It was challenging when I was in college. I took 4 semesters of Greek and I was a math major, so I used a lot of Greek symbols. And sometimes when I was writing papers by hand, I would write a lot of letters in Greek. And so when people go back and read my paper, they're like, what does that say? I was like, well, that's obvious. They're like, why'd you write a P? You were supposed to write an R. I was like, oh. Or I would write, for my E's, I'd write epsilon instead of, anyway, whatever. Okay, you guys are bored. So we got k equals that. And phi must satisfy cosine of phi is equal to b, or a over square root of a squared plus b squared, and sine of phi b over square root of a squared plus b squared. So what we're going to do is it's like, why do this, okay? Well, it makes complete sense. It's trigonometry. Do you know how to graph sine and cosine? Yeah, we would like to take everything really in trigonometry and write it in terms of sine as a sinusoid, as we like to say it. And so if you have a times sine plus b times cosine, you can write it as a sinusoid, where k serves as the, what's the number in front of sine called? What do we call that? The serves with a, rhymes with amplitude. Amplitude, very good. And then we have x plus phi, where phi serves as the horizontal shift. Very good. So if we could write it like that, then all of a sudden we could graph it. So let's look at this. You would have no idea how to graph f of x equals 3 times 2 sine of theta minus cosine of theta. So all we have to do is we have to identify these things. A, b, k, and phi. Phi 5, 4. Oh, gosh. All right, and so we want to write y equals k sine of x plus phi. That's what we want to do. We want to get there. So we're going to. So I would just want to distribute. So I've got f of x is equal to 6 sine of theta minus 3 cosine of theta. If I look, a is a number in front of sine. So what's a? What's b? -3. And k is equal to the square root of a squared plus b squared. So just the Pythagorean theorem. A squared is 36, b squared is 9, so I get square root of 45, which reduces to 3 roots of 5. Don't know why you chose to sit there. Everybody see why I got k? That was easy, right? Now we just need to find phi. So we have to satisfy this. Sine of phi and cosine of phi are equal to 2 particular things. Now, they didn't like this second hour, so I'll try it differently this time. Whoop, you need to go away. I need a calculator. Calculators, go, go. Calculator challenge, race. And Anderson's going to lose. Exactly. You don't even know. That's why I'm going to win. Go, go, gadget. Yes. Okay, here we go. Clear. On. Oh. Okay. Now, sine of phi is equal to, it says, if you look here, b divided by this guy, which is really k, right? So sine of phi has to be equal to, what is your b value? Negative 3 over 3 square roots of 5. And cosine of phi has to be a, which is 6, divided by 3 square roots of 5. Okay? And let's just come up with a decimal for one of those. Okay? So negative 3 divided by parentheses 3 second square root of 5 parentheses, enter, negative 0.4472. Everybody got that? Okay. Now, we only need one. We don't need them both. Okay? Here's what it means when it says it must satisfy both of those. This is the most important part. This is where people get lost. It has to satisfy both. Well, it's the same stinking angle. It's just in different quadrants. So where is sine negative? 3 and 4. Where is cosine positive? 1 and 4. So which quadrant am I working in? I'm working in the fourth quadrant. That's where sine is negative and where cosine is positive. That's the quadrant I'm working in. So when I find this angle, when I inverse this on my calculator, it's just giving me a reference angle. I have to use that reference angle to find the actual angle. So what I'm going to do, is this. What am I going to do? I'm going to do sine inverse. And I'm not going to plug in the negative number. I'm going to plug in just positive. 0.4472. Because it will give me the reference angle in the first quadrant. Now, I got 0.46 because I'm working in radians. Make sure you're working in radians. Yep, we're back to radians. Mode. For this unit, stay in radians. Okay, so we got 0.46. So that's my reference angle, 0.46. Now, I want to draw another reference angle in the fourth quadrant, 0.46. Remember that if we label our radian marks, we have 0, we have 1.57, we have 3.14, we have 4.71, and we have 6.28. So how do I get that angle measure? What do I do? Subtract it from 6.28. So I'll show you a trick here. 6.28 minus 0.46 is 5.82. So phi is equal to 5.82, or phi is equal to, watch this. Would you agree that those are the same? That if I subtract 0.46 off of 6.28, that would be the same as going negative 0.46 in the opposite direction? Would you agree that those are the same? Which one would you like to say is phi? Would you like to use phi as 5.28 or phi as negative 0.46? I like negative 0.46. I'll show you, okay? Let's graph it. So my equation looks like this. I have y equals, what's k? 3 square roots of 5 times the sine of x, and I'm going to use phi as negative 0.46, so I'll go minus 0.46. Think about it, you guys. That's my horizontal the formula says plus phi. Good point. So my horizontal shift is 0.46 units. Would you like to shift something forward 0.46, or would you like to shift it back 5.28 or 5.82? this is a smaller shift, is it not? They would end up being right on top of each other. They're the same graph. It's just a matter of how you're shifting it. I would rather do this shift. So that's what I'm going to choose. You could do the other one, and it would work out just the same. But let's graph it. So when I graph something like this, the nice thing is what's your vertical shift? 0. You don't have a vertical shift. What is your amplitude? 3 square roots of 5. So we'll just put that mark up here. 3 square roots of 5 and vertical shift? No. You do have a horizontal shift here. Do you know what the period is? 2 pi divided by 1, which is 2 pi. So because I have a decimal, I'll mark it out as 6.28 here and negative 6.28. If I divide that in half, I get 3.14. I get 1.57. I get 4.72. And we do have a horizontal shift, right? Okay, so here I go. Where does the sign start? Top, bottom, middle. Middle. Start by going up or down? Up. So I just draw a little rough sketch of my graph. What do I do with all those points? Shift them positive 0.46 units that way, which 0.46 is about a third of this 1.57, third or fourth of that. So let's move each one over a little bit. If we graph this, it would match up perfectly. We're all artists at heart. Beautiful. That's how you do that. What do you think? So when you do that, though, you're going to have to follow your notes, right? So you're thinking, well, you had the notes. You're welcome. I'm just trying to get a pat on the back. All right. So here's what I have for you. 5, 8, and 15 are basically example 3 that we did today. 18 is basically example 4, and then 43 and 44 are example 5. Okay, that should help you out. You can just simply add that to your last assignment if you would like to. If you want to start on a brand new sheet of paper, that's okay. You guys, I mean, your last 2 tests were pretty straightforward, right? Your last 3, you guys did very well on. Your next tests are not going to be quite the same. So just realize that 4th quarter, I apologize, but it's not really going to lighten up. We're not going to get to stuff where you're going to be like, oh, well, this is a piece of cake. Okay? It's going to continue to be challenging. The best thing you can do is stay on top of your homework. So if you've not started 7.1, Simplifying Trig Identities, you're behind and you need to get your butt in gear this weekend. Because I will tell you that if you fail to work on your homework, this test will destroy you. If you keep up with your homework and you stay focused on what we're doing in class and stuff like that, you don't miss a lot of school, you should be good to go. But if you don't do anything, this test will have to serve as your makeup test. All right. Have a great weekend.